Well, hello guys, here Mr. G with another video. This time we're going to be solving a question about acid and bases for the grade 12. However, part of it will be applicable for the grade 11 as well. This one was a question 7 done in the Eastern Cape in September 2023. I will leave the question in the description below so you can answer the question before watching the video. But before we carry on, don't forget to subscribe for the channel and like the video. This question says, consider the ionization of oxalic acid represented by the following balance equation, and then you have a balance equation there. The concentration of each of the substances found is 0.1 mole per cubic decimeter. Solution of H2C2O2 at equilibrium is given in the table below. And then in the table you can see the substances and you can see the concentration. Define an acid according to Lowry-Brønsted theory. And this one may be the easiest definition that you're going to have. An acid is a proton donor. If you say that, you get 2 marks without any problem. Write down the formula of a base in the above reaction other than H2O. So let's quickly identify here the acid and the bases for everyone. So to do this one, we're going to find out and determine the families from reactants to product. For instance, you can see that one and this one's a family, let's say. And then we have that these ones and these other substances are family as well. So we're going from reactants to product. In this way, what is happening to that substance as it came from reactants to product? You can see that 1H plus is gone. I'm going to write an arrow like this to say is gone. It loses that one. Therefore, this substance is the acid. Okay, and its family in the product will be the conjugate base. Alright, so that substance is the conjugate base. So if we go to the other, H2O is coming to H3O plus, you can see that is happening is it took 1H plus was taken in. So therefore, this one is the base, as they say in the question, and this one will be the conjugate acid. So the question asks, write down the formula of the base in the above reaction other than H2O. Well, that one will be the conjugate base. That is the one they're asking you here. And the answer then, it will be H, will be H C2O4 minus. That is the answer. And if you say that, if you write that formula, you'll get 1 mark. Is oxalic acid a strong or weak acid? Now, my recommendation is to learn by heart some of the strong and weak acid. Oxalic acid is a weak acid. That one is for sure. Now, explain your answer. Why is a weak acid? Because it does complete incomplete ionization, or ionize incomplete in water. So what you have to say here is that it ionizes incomplete in water to form a low concentration of H3O plus. And quite simple, if you say that, you'll get 2 marks by identifying weak acid. If you perhaps say strong acid, then you will lose this 2 marks. A concentrated sodium hydroxide solution is diluted with water to 1/10 of its original concentration. Now we are in a new question. Exactly 35 cubic centimeter of dilute sodium hydroxide solution is mixed with 25 cubic centimeter of hydrochloric acid solution of concentration 0.1 mole per cubic decimeter in a flask. Alright, so now what you need to know is that the sodium hydroxide used here is the diluted one. The diluted one to the 1/10 of the original concentration. That is given to you. Okay, a neutralization reaction okay in the flask according to the balance equation, and this one is the balance equation of hydrochloric acid, sodium hydroxide. Remember, this sodium hydroxide here is the one that is diluted to 1/10 of the initial concentration. Calculate the initial number of mole of hydrochloric acid in the flask. Now, what do we know here for this question? Let's write 7.2.1 and let's write here data for sodium for hydrochloric acid, because the question is asking about hydrochloric acid. So let's focus on what we know about hydrochloric acid. We know that the concentration is equal to 0.1 mole per decimeter cubic. They are telling you the concentration of the hydrochloric acid. They are also telling you the volume of the hydrochloric acid, which is 25 cubic centimeters. Alright, and we are looking for the number of moles. Very easy. So what is the formula we are going to use here? Concentration is equal to number of mole divided by volume. I'm doing here on the right. So we substitute, however, remember for this formula, this volume must be in decimeter cubic. So I'm going to convert it here. You say 25 divided by 1000, and that will give you in decimeter cubic. So this one will be 0,025 cubic decimeter. Okay, there we go. All right, now if we substitute, all we have to do is to substitute. This one is 0,1 is equal to number of mole divided by the volume, which is 0,025, and then the number of mole will be equal to 0, let's move it here a little bit to the side. Number of mole is 0,0025 mole. That is the answer. Quite simple. One for the formula, one for the substitution, one for the final answer. There is 3 marks for that. Very easy question. The pH of the final solution is 12. So now we know the pH is equal to 12. So the solution is a basic solution. Calculate the concentration of the hydroxide ion in the final solution. Okay, so let's approach this question in the following way. 7.2.2. Okay, so what we are going to do? We're going to use the pH. pH is equal to 12 to calculate the concentration of the hydronium ion. So we know that pH is equal to minus log multiplied by the concentration of H3O+. Okay, so using this one, we are going to calculate that concentration. So if we substitute here, pH is 12. This is equal to minus log concentration of H3O+. This one is what we are looking for. Okay, so how do we calculate the concentration of H3O+? And this one is, in case somebody doesn't know, you say 10 to the power 12 negative to the minus 12, and this one will give you 1 times 10 to the minus 12. That is mole per cubic decimeter, because it's concentration where we are calculating here. Now from here we are going to go to the kW, and let me show you here. kW, it is here in the formulas. You can see here everything that you need, guys. So here is the kW, and the kW have the concentration of 3O+ and OH, which is what they ask in this specific question. So this one is the one we're going to be using here. So you come here and you say kW is equal to the product of the concentration of H3O+, which we know already, multiplied by the concentration of OH minus. And all that is equal to 1 times 10 to the minus 14. 1 times 10 to the minus 14. So using this one, we are going to calculate the concentration of hydroxide ion, which is the question here. So this one will be 1 times 10 to the minus 14 is equal to the concentration of H3O+, which we know because it was calculated here. It is 1 times 10 to the minus 12 multiplied by the concentration of OH minus, which is what we are looking for. When you rearrange this formula, you will get that the concentration of the OH minus is equal to 0,01 mole per cubic decimeters, and that is the answer. If you do this, there is one question for writing the pH, which is the one question for substituting the 12, one question for writing this substitution here, and one for the final answer that will give you a total of 4 marks. It's quite simple. There's another way to approach this one, which I am not going fully to explain, but you can say that the POH is equal to minus log of the concentration of OH. You can also do that, OH minus, for instance, and then from here you calculate the, okay, that is the question, but you can say that pH plus POH is equal to 40. So coming from here, you can go there. But I think the first approach is the most accepted one, is better, so I recommend it there. Question 7.2.3, calculate the concentration of sodium hydroxide. And this question is a little bit more tricky than it actually looks. You need to know and go back to 7.2.2, where they say that the final solution will still have some OH concentration. So there is concentration of OH in that solution. And we're going to solve that question here. Okay, so what is important to know here? At the end of the reaction, there is still going to be some concentration of sodium hydroxide. There is still going to be number of mole of sodium hydroxide. It's in excess. They're telling you that the POH at the end of the reaction is what you calculate, the concentration of OH. Okay, so what we are going to do first, let's come here and say that the sodium hydroxide, NaOH, right, is going to dissociate into Na plus and OH minus. And you can see that the ratio here is 1 is to 1. So if we use the ratio is 1 is to 1, for example, the sodium is not important right here. So using this ratio, if the concentration of this one is equal to 0.01 mole per cubic decimeter, it means that the concentration of the sodium hydroxide here is going to be 0.01 mole per cubic decimeter. Alright, now this is the concentration of the sodium hydroxide at the end. Concentration of the sodium hydroxide at the end. Okay, so using this one, we can calculate the number of mole of the sodium hydroxide at the end of the reaction, and this one is equal, let's write the formula, concentration is equal to number of mole divided by volume. Now this one is at the end, so I'm going to highlight here end. Why I'm saying that? Because at the end, the volume, the total volume will be equal to 35 cubic centimeters plus 25 cubic centimeters. This one is coming from the NaOH, sorry. This one is coming from the HCl. That is the total volume. So the total volume at the end is 60 centimeter cubic. Right? This is equal to 0.06 cubic decimeters. So be careful with this one. Therefore, if we calculate here, we have the concentration is 0.01, and this is equal to number of mole. We're looking for the number of mole of the sodium hydroxide at the end of the reaction. Alright, divided by 0.06, and then the number of mole here, number of mole of NaOH, and I'm going to write here at the end. Alright, this is equal to 0.0006 mole, but let's write it in scientific notation, 6 times 10 to the minus 4 mole, because the number is a little bit too small. So what is this? This is the number of mole of the sodium hydroxide at the end of the reaction. So be careful with that one. Number of mole of the sodium hydroxide at the end. We need to know what was the number of mole that reacted during the reaction. How much number of mole is gone during the reaction was used. So reacting, we can say that the ratio of HCl to NaOH is 1:1. If we go to the reaction, we can see the ratio is the numbers at the front. Now we are looking during the reaction. So this is the number of mole reacted. So if this one was 0.0025, then it means that the number of mole of NaOH reacted is equal to 0.0025 mole. This is the number of mole of the sodium hydroxide that reacted during this reaction. So what is the total number of mole? When we say total number of mole, we're referring to the one that is reacted plus the one that is in excess, the total number of mole of sodium hydroxide during this reaction. So the total number of mole will be the addition of 6 times 10 to the minus 4 plus 0.0025 mole, and this one will be equal to 0.0031. Guys, you can work in scientific notation if you want. This one is the total number of mole of sodium hydroxide that was used. This one, if we go to the question, will be the total amount of the sodium hydroxide that was used in this reaction, the total amount they ate there, okay? The total amount. So now from here, we can calculate the concentration of the dilute sodium hydroxide, NaOH. This is the amount, the concentration of the amount they added in this reaction, and this one is equal to number of mole divided by the volume. So when we substitute here, we have that the number of mole is 0.0031 divided by the volume of the dilute sodium hydroxide, which was 35 cubic centimeters, so it's 0.035. Okay, when you solve that one, you will get that the concentration of the dilute sodium hydroxide is equal to 0.0, let's write 886, let's leave it there, mole per cubic decimeter. Okay, now this one is the diluted. The concentrated will be, the final answer will be the concentrated of sodium hydroxide, and it's going to be equal to 0.0886 times 10. The final answer will therefore be 0.886 mole per cubic decimeters. Guys, this is the final answer of this question. It's a very good question. It's a very tricky. Now, even though it is tricky, doesn't mean you're going to get no marks there. It is not that bad to get mark. There is 1 mark, for example, for calculating the mole, the number of mole of excess, which is in this case here. So it's 1 mark for multiplying, and this one here is 1 mark for doing that. There is 1 mark for getting this ratio, which everyone can get because it's the same one, it's the reacted one. There is 1 mark for adding these two number of mole to get the total number of moles there. There is 1 mark for the substitution, for this substitution here, and there is 1 mark for the final answer. We have 1, 2, 3, 4, 5 marks. It should be a little bit more. Oh yes, it's 1 more mark for multiplying by 10. There we go. And this is the whole. So it's a very good question. I hope it helped. Very good question to practice. Thank you for watching. I hope it helped. Thumb up, subscribe for the channel. I'll see you next time. Next time we're going to be solving a question on a galvanic cell. I'll see you next time, Mr. G here.